In this video, we're going to find binomial probabilities from 4.2. I'm going to go ahead and use technology on all these problems because technology and the formula method are equivalent to each other. And none of these problems are suitable to use tables because they do not have p-value probabilities that are going to be in the tables. They are things that are not multiples of 5 or 10 that are likely on the table. So for instance, this probability here, P is 39% of adults have very little confidence in newspapers. You randomly select 11 US adults, find the probability that the number who have very little confidence in newspapers is exactly 6 and then exactly 1. So this is a binomial PDF situation because it's exactly equal to, so second distribution. I'm going to come down to binomial PDF right here. We'll talk about CDF in a little bit, but there are 11 people here, so 11 trials. P is 39%. And we want first the number of people who have very little confidence is exactly 6 out of the 11. And so that's going to be 0.137. Then we're going to change that to be exactly 1 instead of 6. And that's going to be 0.031 when we round to 3 decimal places. Now, 42% of US adults have very little confidence in newspapers. You randomly select 10 US adults, find the probability that the number of US adults who have very little confidence is exactly 5, and then at least 6, and then less than 4. Okay, so we're going to be doing some PDF for the first one. Then we'll be doing some CDF stuff for the second one. Let me go ahead and list out the options of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 people that feel this way out of the 10 adults that we have that'll help us with the CDF situations in just a second. So exactly 5, we're going to come in here and we're going to have 10 people for our N. And now we have 42% for our P, and we want to have exactly 5. So this is going to be 0.216. Now we want greater than or equal to 6. We don't have a greater than or equal to with our calculator. So we want all this here. That's what we want to keep. So we want to get rid of all of that. So everything that I just X'd off is X less than or equal to 5. Our calculator can do that. So let's take 100% minus second distribution, binomial CDF, which is a less than or equal to statement. And we're going to have 10 trials. We're going to have 0.42 for our p-value. Our upper limit here is going to be 5 that we're less than or equal to. And so that's going to give us 0.202 when we round to 3 decimal places. And then it says strictly less than 4. Well, again, we can't do strictly less than. We have to do less than or equal to something. So the first number that's less than 4 that we can be equal to is 3. So we're going to change this statement to P X less than or equal to 3. Second distribution, binomial CDF. And we're going to change this to 3. And we have 0.333. Right. One more problem here. 37% of college students say that they use credit cards because of the rewards program. You randomly select 10 college students and ask each of them to name the reason he or she uses credit cards. Find the probability of the number of college students who say that they use credit cards because of the rewards program is exactly 2. And then more than 2. And then A, B, C, between 5 and 2 inclusive. And if convenient, use technology to find the probabilities. Awesome. So let's go ahead and find a binomial PDF for the first, where we have 10 trials, 37% probability, and we want x to be exactly equal to 2. And that's going to be 0.153 when we round to the nearest thousandth. Thousandth is 3 decimal places. Greater than 2, that's going to be 1 minus x less than or equal to 1. So 1 minus distribution binomial CDF, 10 trials, 0.37%, x value of 1. And so we have 0.932 when we round to the nearest thousandth. And then between 2 and 5. So we're going to have less than or equal to 5 minus less than or equal to 1. Let me show you that. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want all of this minus these. That'll be 2 to 5. So we've got 2 less than or equal to statements here. So second distribution, binomial CDF. And just make this one 5 minus distribution binomial CDF, and then make that one 1. To find the difference there is 0.812. That's it for this video, and that's it for chapter 4. We'll come back next time and we'll start talking about chapter 5. See you for the next video.